students, today's lesson is on ratios and rates. Let's go ahead and start with some definitions. A ratio is a comparison of two quantities using division. So you can see we can use a fraction bar, we can use the word to in order to compare the two quantities, or we can also use the colon. A rate is the ratio of two quantities that have different units. So for example, 60 miles per 2 hours would be a rate because we have the units of miles compared to hours. And then last, a unit rate is a rate with a denominator of 1. So 60 miles per 2 hours is not a unit rate, but 30 miles per hour is, because we're seeing how far does this vehicle go in 1 hour. Let's go ahead and look at some examples of writing ratios and rates. So here we have this situation that there are 45 males and 60 females in a subway car. We need to find the ratio of males to females. So we're going to start by saying males over females. And we see that there are 45 males and 60 females. Now, we can reduce this ratio because both numbers are divisible by 15. So when we divide by 15, we get 3 over 4. So that means for every 3 males, there are 4 females. All right, we also have the subway car travels 2.5 miles in 5 minutes. And we need to find the speed of the subway car. So we're going to write this as a unit rate. We're going to start by saying we want miles per minute. And we see that the subway car goes 2.5 miles in 5 minutes. Now, to write a unit rate, we want to know how far does the subway car go in only 1 minute. So to get from 5 to 1, we divided by 5. We're going to do the same thing with miles and get 0.5 or half of a mile in 1 minute. Here's our next example. We're going to use a ratio table to find a rate. So here we have a ratio table that shows the cost for different amounts of artificial turf. And we can see that it costs $100 for 25 square feet of turf. We can continue this table. We want to figure out what's the unit rate in dollars per 1 square foot. So we want this number to be 1. Which means we're dividing by 25. We need to divide by 25 here, and we get 4. So our unit rate is going to be $4 per 1 square foot. And we want to have, since we know we want a unit rate of dollars per square foot, we want that 1 square foot on the denominator of this rate. All right, one more key piece of vocabulary. A complex fraction is a fraction with at least one fraction inside it within the numerator, the denominator, or both. So this is why it's complex. And we can simplify these complex fractions down into simple fractions. So let's look at this example of finding a rate from a graph. We see that the graph shows the speed of a subway car, and find the speed in miles per minute. We're going to compare the speed to the speed of the subway car back in example 1. So we'll go back and do that. But let's look. Step 1, we're going to choose and interpret a point on the line. So we have a couple points marked. Let's take this first one. 1/2, 1/4. That's talking about the x value is 1/2, which is minutes. So in a half of a minute, the subway car goes 1/4 of a mile. So let's go ahead and just write that out first of all. So our point is going to be 1/2, 1/4. And we're going to interpret that as 1/4 of a mile in 1/2 of a minute. All right, so now we're going to find the speed. So we want to find the speed in miles per minute. So we're going to do 1/4 of a mile over 1/2 minute. So you can see we have this complex fraction where we have a numerator and a denominator, but the numerator itself is a fraction and the denominator itself is a fraction. But we know that fraction really, this fraction bar means divide by, right? So what we really have here is 1/4 divided by 1/2. And we know that when we divide by fractions, that's multiplying by the reciprocal. So that's 1/4 times 2/1. So we can simplify that to 1/2. Now we still want our units here, and we had miles over minutes. So that's still going to be our units. It's 1/2 of a mile per minute. So every minute we're traveling 1/2 of a mile. All right, I think that is it. Oh, nope, we've got one more. We're going to look at our ratio problem here. So we have 1/2 of a cup of yellow paint for every 3/4 of a cup of blue paint in order to make 15 cups of green paint. So we're going to use this ratio table, first of all, to solve the problem. So we know for every 1/2 of a cup of yellow, we have 3/4 of a cup of blue, right? So if that's all we mixed, 1/2 of a cup plus 3/4 of a cup, that would be 2/4 plus 3/4 is 5/4 of a cup. Now, we're going to use this ratio table to try to find 15 cups of green paint. So let's start by trying to get this denominator out of our total. So let's multiply everything by 4. We're going to take this solution that we have, we're going to keep the same quantities, but we're going to make 4 times as much. So 1/2 times 4 would be 2, 3/4 times 4 would be 3, and 5/4 times 4 would be 5. So therefore, if we use 2 cups of yellow and 3 cups of blue, that would make 5 total cups of green. Now remember, our goal is to get to 15 cups of green, so that means we're now going to multiply by 3. And we're going to do that in every column. So 2 times 3 is 6, 3 times 3 is 9. So if we use 6 cups of yellow and 9 cups of blue, we'll get 15 total cups of green. So that is our first method of using a ratio table. Let's go ahead and use another method here of using a complex fraction. So on this one, let's go ahead and start with yellow over green. So we're going to try to figure out, for any given amount of green, how much of that green solution comes from yellow, right? So we're going to start with, we knew we had 1/2 of a cup of yellow for every 1/2 plus 3/4 of a cup of green, right? This was the yellow and this was the blue. So we can simplify this to say, well, that's 1/2 cup of yellow for every 5/4 cup of green. Again, we know that this fraction bar means divide, so we're going to change this to 1/2 divided by 5/4. Okay, now we're going to change our division into multiplication by saying that's really 1/2 times 4/5. Right? That means the same thing if we multiply by the reciprocal. Now we can simplify this and say that's 4/10 or 2/5. So for every 5 cups of green, 2 of those cups are yellow. That must mean that for every 5 cups of green, 3 of the cups would be blue. So if we're wanting to answer this question about how much yellow and how much blue for 15 cups of green, we would take this 2/5 and multiply by 15, and let's say 15/1. We can simplify here. We get 2 times 3 is 6 cups of yellow. On the other hand, blue was 3 out of every 5 cups, so 3/5 times the 15 cups of total green, and we get 9 cups of blue. So we solved this problem using both the ratio table and the complex fractions, and either way, 6 cups of yellow and 9 cups of blue is what we'll need for that solution. Okay, now I think we're done. So go ahead and try a few on your own, and I will see you soon.